Right. Welcome everyone to Omaha Data Science Academy. This is the Cloud API or Cloud Solutions and API Integrations class in Omaha Data Science Academy. I am Jeremy Bergman, the instructor, and tonight's class is over Advanced API Integrations for Data Science. So first I want to cover the syllabus for the students in the class. Previously, we were working towards the Microsoft 203 DP203 exam and the content and questions related to that. But in lieu of some barriers and roadblocks and challenges and configuration, we're going to change this class up a little bit. So the good thing is in those first four classes, we've learned introduction to cloud engineering, how to work with APIs, and our first two sections on cloud engineering, which is cloud storage and databases and cloud processing. So that hasn't changed. So we're still on track as far as content-wise with how we would usually teach this course. But now we're just removing aspects of the 203, DP203 Microsoft exam. One, they're just causing barriers in configuration, and two, there are challenges with getting Databricks configured.
Hey,
So, yeah.
Sorry to interrupt. Are we supposed to be seeing something on the screen? I don't see anything. I don't know if you were sharing the syllabus.
Yeah. I'm just kind of talking to it at the moment, but good call.
Thanks.
So, yeah, we're going back to like a previous version of the syllabus that was students had success with instead of those type of challenges. And really the DP203 exam was and it just adding more to an already packed class on top of it. So this no longer follows the DP 203 exam. I posted the new syllabus within Slack. But to cover really quick, we're changing up a couple things. So we're having challenges configuring Databricks. So tonight we'll just cover Azure Synapse Analytics instead. It's a really similar environment and much easier to configure than Databricks has been. Plus, it has the technologies in there. It has pipelines, so Azure Data Factory pipelines. It has Spark and Spark notebooks, and it has its own SQL database. So all the things that we've been learning so far are all contained within Synapse Analytics. And the timing is actually perfect to change up this class because we've learned those core things which have been the same through each class that we've taught. And instead of moving forward to Databricks, I can just now teach a class on API integration. The API integration for data science and analytics using Synapse Analytics instead. So the cutoff time, the change was like right for it. It's getting late in the class, but given our challenges, I think it's a good change. So two things, that's a major change in the classes using Synapse Analytics instead. One of the other things I'm going to do is for model building in the next class, I am going to create a lecture that utilizes Dataiku. So Dataiku is like a machine learning and AI building platform. So a lot of these platforms are really similar and have similar features. CAN has used this in the past to for some of their clients to be able to have a cloud platform where you can import data, build machine learning pipelines, manage data, create notebooks, everything that you would do within like Azure Data Factory or Azure Machine Learning or within Databricks, probably without as much hassle. And then at the end, we'll deploy the machine learning model in a similar way that we would with in a similar way that we did with that we would otherwise with Databricks or within Azure. So we're just replacing this one. We're just replacing 2 technologies to make it easier in the configuration, not as difficult. Even within the 2 previous classes where I've taught it with Azure Machine Learning or with Databricks, we've run into configuration challenges there too. And Dataiku is already pretty much pre-configured and easy to use. So we'll just focus now on replacing the technologies and really the core principles of engineering, cloud engineering, utilizing APIs to build machine learning model and deploying those. So MLOps and how to deploy an end-to-end machine learning or AI solution in the cloud, how to engineer it. And I think that's a good path to take because just adding in the Microsoft stuff on top of it was complicating everything and making everyone's lives difficult. I'll actually drop anybody who wants to get a little bit of a look at Dataiku that we'll be using in the next section. And that's our next class. We'll do a model building and deployment class in our next class. So it doesn't really change the rest of the class up too much, except for the current lecture, we'll do Synapse Analytics. And then we'll move an overview of real-time analytics here to the end. We'll do a monitoring, security, and optimization class too. I might do the real-time class there. I haven't quite decided yet, but we'll cover monitor those and real-time analytics also. We won't go too deep into those because at the end we want to be able to catch up and then build and deploy this solution. But I think learning more about these other data services and tools that you have as a cloud data engineer, like real-time analytics and monitoring, optimization, and security, will be useful for us too. But it won't expect you to do it so much for your final project as much as having the knowledge of it at the end. So class stays pretty much the same, except reintroducing Synapse Analytics into it, and then moving real-time analytics down here to the end as a topic we cover instead of deep dive into. And then all quizzes and the final exam we'll no longer do it related to DP 203 exam. I think in the future, like I said, in the future, maybe we do that. If people are interested, just let us know. Maybe we teach it in a separate class if people want to do a certification path and certification exam instead of trying to combine it into this 4-week class. Any thoughts or questions? And we've completely dropped Databricks and Azure Key Vault. Those are just causing people problems too. So we'll just move forward without those two, which are things that I added to this syllabus that are no longer needed. Right? Sounds good? I think it will I think it's going to remove a lot of barriers for our learning. Okay. So we'll go ahead with tonight's lecture. So One of the things we'll do with tonight's lecture is learn more about Synapse Analytics and its different components and how we can use it. You're going to see a lot of familiarities between what we've already done and Databricks and the content that we've covered, which is good. So it's not like we're starting all over or anything. But we're going to do this, and then we're going to we'll revisit homework 1 and do that with what it looks like with Synapse Analytics instead. And then we'll also do the hands-on exercises that we didn't get to from last week, the storage and the data processing exercises. We'll do those using Synapse Analytics. And then the assignment will be to create a pipeline that you'll create a pipeline within Synapse Analytics that connects to the live coin launch API to be able to get data and put it in your data warehouse. And I think I'll try to get it to a demo, kind of a demo, and show people what that looks like to set up in this class too. Okay. Let's get after it. The good thing is, like I said, just reassuring everyone that as we are reframing this class a little bit, we are in a good spot with what we previously learned. It's just switching up the technologies now and focusing on the principles of cloud engineering instead of trying to do that and try to do all the stuff needed for the 203 exam, also configuration and setup and so forth. All right. So go ahead and start the lecture. Say a relatively shorter one, and we'll learn all about this. These are going to seem fairly familiar to you because a lot of it's Synapse Analytics is like that all-in-one data engineering platform that includes database pipelines, Spark notebooks, and so forth. So it's bringing all those pieces together that we've already learned about. And then we already have Data Lake set up also. And we've learned about Data Lake and a little bit about Delta Lake also. So we get to apply all of our principles, just bringing it together in new technology or a new Azure data service. Okay. Go ahead and present. Go ahead. And I'm losing my mind where I usually go. Get the danger, we'll just ignore that. All right. So this class currently structured gave you an overview of Synapse Analytics. It's like that all-inclusive data service that Azure has that includes a lot of these core technologies that we've talked about. So it includes storage. It includes a SQL data warehouse. It includes pipelines like Azure Data Factory, a little bit of a simplified version of Azure Data Factory, but it'll be perfectly good for us to practice some of those things that we learned about Data Factory. It's basically the same, just a little bit of a scaled down version that we can use within this analytical platform. Also, Spark notebooks where you can write Python, you can do distributed computing, and then it's highly integrated with other Microsoft services. So we can also connect it to our data lake. We'll eventually connect it to Power BI to monitor our models. And then we'll even be able to connect Data IQ to Synapse Analytics to be able to we'll be able to connect to the Synapse data warehouse to be able to get the data that we need to build and deploy a model. So ultimately, it has all the technologies that we need in one spot. In hour 2, we'll go a little more hands-on. We'll do an overview here in this first hour. Shouldn't take too long. Hour 2, we'll get our hands on and see how we would collect data using APIs, data pipelines within Synapse. So I call them Synapse pipelines, and then the Python notebooks. We'll work on all of those to see how data is collected. And then finally, with our hands-on, I talked about we will go back first and do our homework 1 and the hands-on exercises from last week. But this will be one of our hands-on exercises for this class, is taking those CSV files and putting them into the SQL data warehouse, but then also creating a automated pipeline using the REST APIs, and talking about that a little bit, like the importance of being able to connect to REST APIs and data science and get the most updated data so we can continue to update and refresh our models or analysis or whatever we're doing. All right. So that's how it's structured. Specific objectives. Look at Azure Synapse Analytics platform. It's that integrated platform and the components I discussed. We have Synapse Studio. That's like the interface for Azure Synapse. It's a data engineering integrated development environment. If you think of like your Python or your programming integrated development environments, it's kind of like that place that you can go to make your life easier. It's like you have different add-ons that help you autocomplete code, or connect to GitHub to be able to save different versions of it, or be able to scroll through your file directories or set up projects easier. This is what Synapse Analytics does. It just does it from a data engineering and a cloud perspective. It's not quite a programming IDE in its sense, but the integrated development environment is that it brings all of those tools that make data engineering easier all together in one platform. And then we'll see the IDE is like the interface, the integrated development environment and interface. So we'll take a look at that a little bit more. We'll take a look at that in some detail. We have SQL pools, serverless and dedicated. You have the serverless. This is related to data warehouse. So you can call it on demand. Doesn't necessarily have to be running all the time, or you can dedicate it so it does run all the time. But the advantage of this is a high performance pool here in Synapse Analytics. It's usually a little more expensive than SQL databases we set up, but work perfectly fine for what we're doing here, and you'll see it in action and how well it performs on data. One of the examples here that you can do is set up a SQL pool and then query data lake data sources directly using the SQL service pool. That's one of the examples that we'll do here during the lecture. So instead of having to load up that file in a table, you could connect to that within your data lake and then be able to write a SQL-like query to be able to return results for that data that's in REST. We'll revisit Spark pools and PySpark. We'll do a data frame example. It's what we did a little bit with Databricks while we were doing it, or we did within Databricks. We tried to configure and spin up Spark pools. Now we'll go into it a little bit more on how you can load data into data frame. And then the last part's automating data collection using APIs. What are the importance, benefits, real life applications, and then how you do it within Synapse Analytics in a data factory pipeline. All right. So I've done some describing of this already, but this will give us our bullet points. So what exactly is Azure Synapse Analytics. It's like that all-in-one platform for analytics projects. It helps integrated development environment for data scientists, data engineers, and data analysts to be able to go to and be able to utilize the same tools, like a shared integrated development environment. Plus, it has all of those tools that we just talked about. So highly integrated with Azure Gen 2 storage. So that's your data lake storage. We already have that set up. We'll integrate that today with Synapse Analytics. Data warehousing. So it has a SQL on-demand pool and the highly performant database there that we can utilize within Synapse Analytics for data warehousing. Analytical processing. So that, if that sounds familiar, we did data processing in the cloud the last lecture, and we can use the on-demand Spark pools there. If we need to process things programmatically, or maybe it's a huge data set that you need to be able to break down in pieces. So it's big data. Being able to process it. Can do data analytics. Power BI is integrated into Synapse Analytics. Machine learning is not, although you can create machine learning models in your Apache Spark notebooks and run them as part of a pipeline that way. We won't be doing too much of that in the class because we're going to use Dataiku to build our pipeline. But knowing is that ultimately you could build a pipeline. You could always build machine learning models in Python, as I'm certain that you did in your machine learning class, and deploy them through Spark and schedule them in a pipeline in Synapse Analytics. Has data processing features, Data Factory, Data Explorer, and data flows. So your Data Explorer is, we covered it briefly in the last lecture, is a way to be able to query real-time or streaming data. And then your data flows are like your parts of your data pipeline or the transformations that you can make for the data within your Data Factory or Synapse Analytics pipelines. So you can create a data flow that transform in multiple steps data flow, and built for collaboration between data scientists, data engineers, analysts. And I forgot the most important part is your customers, which are usually any number of people within an organization, company or organization. Features, diving a bit more into the specifics and the architecture of Synapse Analytics. It's integrated analytics for big data and data warehousing within the single Azure Synapse Analytics resource within Azure. It does also include Power BI. I thought it did. And then for analysis, Data Explorer. I didn't think the Data Explorer was part of this, but it may be. So data integration, you have the Azure Data Factory like pipelines. And then the data flows I just talked about. You can map data and transform data within these pipelines for analytical purposes. On-demand query processing, you could do that with serverless SQL pools, SQL on-demand pools. And you have Apache Spark integration for big data. And then you could do your programming languages, Spark, SQL, Python, Scala, and so forth. So you could connect to your data in two ways. You can write SQL through an on-demand pool, where you can write code within a Spark SQL notebook also. So management tools, these are the things data engineers have, like your monitoring and management and security, and then your developer tools. You see within notebooks, you have SQL, Spark, Scala, even C#, and then you could use Git for version control. If you connected Git to this, you can go back and forth between different versions of notebooks or data sets and so forth. So pretty much everything is included here that we've talked about that you'd like to have in a data engineering toolkit. That's one of the attractive things of it, is that it's all here in one spot for data engineers. Plus, it's that integrated, highly integrated development environment for everything related to Microsoft and Azure also. So you could have other resources that you set up outside of this and then connect to those resources also. Maybe you set up a MySQL database. You could connect to that through Synapse Analytics and use it as a data source through a pipeline. All right. So Synapse Studio IDE. Synapse Studio is the unified web-based user interface for Synapse, Azure Synapse Analytics. So they call it Synapse Studio IDE. Serves as a central hub where users can manage and monitor all aspects of their data solution. Other things that you can do within it: create and run SQL scripts, integrate and analyze data using notebooks, build, manage, and monitor jobs. So you can do that through this integration or pipeline. Design data pipelines, of course, then access built-in data exploration tools like Power BI and Data Explorer. Data Explorer must be an integrated piece now with Synapse Analytics. But if you look, you have your home screen, you have your data sources. So this is where you could set up connections to like external data sources or those services, like a external MySQL database within Azure. Maybe even, we talked about hybrid cloud, maybe even set a connection to something that's on-premise, that's not in the cloud. You can set up API connections there, which we'll try to do. We'll try to do that today. And then put these all in pipelines that you can monitor and manage. So I'm going to go ahead and bring this up so we can take a little bit of a look at it. Okay, so if we go to portal.azure.com, so we're going to just go to our portal the way we usually do. And then do a resource group. I actually don't have it set up at the moment, but we'll go ahead and go through that. Click on data engineering. So far, I only have these services set up that we've already used. So you can create this service in the usual way. Through your marketplace. Use Synapse Analytics. One of the most popular. You can create that service. And then configure it in a very similar way that we've done in the past, and then connect it to your Gen 2 data service. So instead of taking you through the interface right now, we'll wait on, we'll go ahead and wait on configuring this until the third hour. But let's see if we can pull something up. you did Synapse Studio walkthrough, we could do one pretty fast for everyone. We'll do that guided video until we get it set up. So go ahead and put this in Slack, something that we can look at over the break. Okay. So I'll get you familiar with this. This is kind of was what it looks like once you go to your workspace within Synapse Analytics Studio. So you'll see this. The whole guided tour will give you a heads up into what it looks like from start to finish through the Azure portal. Okay. So thing you'll want to do is start looking at the different components. And one of them is the Synapse SQL pools. So these are like in Synapse, they call these the Synapse SQL data warehouses. It's intended as like an analytical data store, like that online analytical data processing I often refer to. But it's to store data and information. So transform data usually, but to store data for analytical purposes. So it has two distinct functionalities. You can do on-demand queries. So it doesn't always have to be running. It can run just whenever you need to run a query. So you can imagine could be very much cost-saving utility to be able to just not always have to have like something that's highly performant and high compute always running, is that you can just run it whenever you need it. So it just starts up like we've seen within Databricks. It just starts up your resource and your compute. And then once that's started, it runs a query for you. And one thing that you can do with it is that you can query your data directly from the data lake, whether it's in CSV, Parquet file, or JSON. What's good is that now we can just store a JSON file and try to query it that way. CSV is the most straightforward because it's tabular data, where you can do Parquet data format, which we talked a little bit with Delta Lakes, but that's like your data cube format that is highly performant for data, multi-dimensional cube that you can query. You can load your data into in the data lake, and then you can query that multi-dimensional cube. So your dedicated pools, those are the ones that are always on and optimized for large-scale data warehousing. A huge organization may just need it to work all the time. Like you're constantly loading data into the data warehouse. That's when you would use a dedicated SQL pool. So not nearly as much as if you're only doing it a couple times a day, which is common for a lot of organizations if you're doing it like once or twice a day. But if you're constantly loading data into that Synapse SQL pool, like near real time, you'd want a dedicated SQL pool. So the dedicated resource is scalable, like a lot of things in complex analytical workloads with performance. So I'll go ahead and drop this in there also. I'll have a couple of videos to watch over break. Synapse SQL pools. All right. Let's spin those up and show how they work. An example of the data lake query, this is what it looked like and how you would use the Synapse serverless pools, or the serverless SQL data lake queries. So what you can do, we'll go ahead, we'll set this up. Not right at this moment, but we'll go ahead and set this up for our exercise at the end. So what it would look like with Azure Data Lake Gen 2. So you'd use if you don't have one set up, you would create your name, and then it could create a data lake inside of there. But you could also connect to an existing data source also. And within that, you can connect to your CSV files. And then you could run a query that looks like this out of your data lake. So it'd be your data lake server name, and then your folder that you have it stored in, and then whatever your CSV name is filed, if you're if your files CSV format. It can be a couple different formats, like I said, like Parquet or JSON. And once you have a linked data source, that's when you could use that, and then you can create results without having to listen to it first. That's one of the uses for SQL, the serverless SQL. The other one is like a SQL relational database, just using it as a database for data warehousing purposes. This is one of the big advantages, is that you can just write these queries. Maybe you load this data into a table in the SQL data warehouse or the serverless SQL server, and then you transform it the way you need, and then you have a analytical data model or your data in your data warehouse that you need available to be available. So 2 use cases for serverless SQL data lake. And then this is how you would query data directly out of the data lake. Okay, so Apache Spark. Mostly covering these so we can get through it and then do a bunch of examples. We'll set up Synapse Analytics, and then we'll go hands-on with these things. So copy this video URL. So this will look familiar because Apache Spark is what we're using in Databricks, but Synapse also contains this too. So that'd be a managed Spark environment like it was there. And Microsoft will manage the provisioning, scaling, and maintenance of Spark clusters. You can also choose your compute, but like we saw, or what we talked about in the last lecture when we were diving deeper into the Databricks, is that when you're running a workload on Apache Spark, it will dynamically decide how much resources you need to be able to run your processing, to do your data processing most effectively. So Microsoft, it's managed service where Microsoft helps you provision and scale for various workloads in an automatic way, like we saw with Databricks. It has a few different languages. You can write Python notebooks there, and that Spark SQL is a nice feature also to write into the Gen 2 data lake. Built-in collaboration with notebooks in Synapse Studio, supports co-authoring and version tracking and so forth. If you set up Git, you can go back to previous versions of your code. Performance optimization, Spark Pool. Yeah.
That video, the last one you shared, I think that's not what you meant to share. It's like a minute long, and it's about reducing the power of the regulatory state.
It is not. No matter how much I try to get away from political ads. I can't do it. It's not even politics season, or it's not even like presidential election season. It is local. It is locally, but yeah, there's like an ad there. I must have clicked hit play and then like hit play and then click the link.
Can you please just hear
me
out? No, all work management platforms are the
annoying.
same. Monday.com is the one you'll actually love.
Yeah, it's behind the scene. The guy in a cube, they're always good with the Microsoft stuff. Here we go. How about this link instead? Yeah, there we go. That guy disappeared. That's good. Yeah, two guys in a cube talking about when to use serverless versus dedicated SQL pools. Exciting stuff. But these guys are definitely, especially the guy on the left there is describes all this stuff in an entertaining way. Generally did it with Power BI. They're like guy in the cube famous with Power BI, but expanded into my other Microsoft products also because he's really good at it. Yeah, it introduces product manager and product manager takes it through it. All right. Apache Spark, we've seen all this before, getting through this, performance optimization, like we've seen with Databricks, direct data access into Azure data storage, lake storage. I think that's like one of the biggest benefits of using Synapse Analytics is that it's directly integrated with the Microsoft products and you can query directly into the data lake. It makes doing ETL, which is extract, transform, or load, or ELT into your data warehouse much easier. For being able to just get that data without having to do a lot with it or trying to store it somewhere to just be able to get the data. It's a really huge benefit. And then ML tool integration, it utilizes Azure Machine Learning Lab and Spark libraries to build ML models. So you can use Azure's data service. They have a machine learning lab, or you can use libraries in Spark to be able to build and deploy machine learning models. That's what I'm talking about at the beginning, is that you can still write Python code to create these models. But in this class, we're going to try to use an interface, like a shared interface between data. And that's one of the particular things that's good about the cloud, is that you have these shared environments and highly integrated environments where people can collaborate and create these machine learning models. And then in particular, we've had the first class, we had all sorts of trouble with configuring Azure machine learning also. That maybe it's better now, but we'll use Dataiku as our platform instead. But knowing that those two tools are available, Microsoft is always improving their services in that you have Spark libraries available. Within the Python notebooks, you can also install libraries. Maybe you'd use scikit-learn or other data science libraries you could use to build models too. The advantage of building an ML Spark library is if that you had very large data sources and you needed to do distributed compute for a machine learning model. You could load up Spark libraries and be able to do that in probably an easier manner, or certainly an easier manner than you would with like a scikit-learn library or something like that. Having to then take that processing and then try to split it somehow. ML Spark will help you, or Spark will do that for you with these machine learning libraries. Why don't I go post a little bit about ML Spark also. Okay, so we have ML Spark library. Okay, so machine learning library guide. MLlib is the Spark machine learning library. It has a bunch of built-in machine learning algorithms. Create your own features, feature engineering, extraction, so forth. Create your own pipelines. So common that these would have pipelines. You can do all your data transformations in there, and all of your set up all your dependencies. Persistence. That's one of the big things I talk about with relational databases, is that you can save and load certain states of the algorithms or models or pipelines or data, and then it's there even if you exit the session. And then you have other utilities like summary utilities or linear algebra practice packages and so forth. But one of the big things is that helps you with pipelines, and then it has these algorithms and that you can build in algorithms that you can do over distributed computing. So I'll go ahead and paste that as a link. Just putting this in, just pasted that into Slack for everyone. We're actually fairly close here to the end of the hour. Yep. And then we have an example of your PySpark data frame. So how you can create a data frame. So this data frame is a little bit different than a Pandas data frame. So it's a Spark object, but it's still generally like a tabular format, but it has like, what would I say? So it has like functions that allow you to do distributed computing on it. So you'll see a lot of things that are like similar to Pandas, if you're familiar with that from your Python programming class, a library like Pandas, where you can like select your columns or you just limit the first 10. You would do a head in Pandas, so the functions might be a little bit different, but ultimately like a similar type of data structure, just works a little bit different in works a little bit different in Spark than Pandas. Let's see if we could come up with something. Spark versus Pandas data frame comparison. So yeah, Pandas will be probably more flexible, but Spark will allow you to process the data in parallel. But there are different things that you can do on these data frames also. Tutorial spot's usually pretty good. Spark data frames versus Pandas data frames. So Pandas is two-dimensional. Key structure. Okay. Pair stage API. Okay, here's some advantages and disadvantages. Go ahead and do this. So advantages of Spark data frames, massive data sets, optimizes it for processing and so forth. Enables parallel processing, of course. Pandas is probably a little more user-friendly with the libraries, allows you to do a lot of manipulation and machine learning and visualization. So Pandas data frame, you can feed that to other machine learning libraries and use the Pandas data frame. Yeah, the advantages and disadvantages aren't that useful in this one basically, but think of Pandas is it's like you're generalized. You can do it within Python and do a ton of manipulation to tabular like data structures, where Spark is And then you can feed these into other libraries. It's very generalized and can be used with other libraries. Spark is pretty much Spark. Is that you use those data frames within that environment to be able to process data and then use specific Spark libraries on it. Now you could take a Pandas data frame and convert it to a Spark data frame also. But that's specifically what you do with Spark data frame. I don't know if it would help you that. It might help you. It might help you if you're pre-processing a bunch of data for your model. The idea is that you can read it directly from, you can create a Spark data frame directly from your data lake source. And then you can display those results after you've created your Spark instance. Okay. So that brings us up to the first break. And there's not actually too much left here in the lecture. We'll come back and take a look at how you integrate APIs in data science workflow using Azure Data Factory or Synapse Analytics pipelines, which is pretty much close to the same. And then some of the benefits. We'll actually take a 20-minute break here because it'll take a little bit to watch the videos that I posted. So go ahead and watch all these videos. This Synapse Studio IDE walkthrough. Oops. It looks like I froze up there a little bit. Synapse Studio IDE walkthrough. Synapse SQL pools. And was I forgetting one more? And then Apache Spark.
With Monday.com, every business.
I'll give you this link here in a second.
Monday.com.
Yo.
Yeah, the guy in the cube again doing that one too. Okay. So this one will be Apache Spark. Getting started with Spark. There we go. I try to watch all these videos over break. It'll take you a good part of 20 minutes to be able to do that. We'll come back at 7:35. Do you watch the videos? And we'll finish this lecture up and then start going back and revisiting some of the homework. And we also need to set up Azure Synapse Analytics. So we'll set up that resource to be able to do some of these examples that we have in class also. Okay. We're going to go ahead and take a break. I'm going to grab a drink and a snack and be back. 7:35, 7:13 right now, Central. Be back at 7:35. Right. See everyone then. All right, everyone, I'm back. Thanks for waiting the extra minute. Grab myself a big cup of joe, settle in here for the rest of the class and knock this out. Right. So hopefully those videos, you're familiar with some of it, but setting up Azure Synapse Analytics or setting up Spark pools, how you could use that, serverless versus dedicated pools, the advantages of each. They made an interesting point in this one about you can turn the dedicated pool on and off, and there's a little bit better performance. But there is advantages to SQL or the serverless as far as just needing it whenever you want. Maybe you only need it for a few queries a day or just a little bit of processing. Azure Synapse serverless is perfectly good for that, and that's what I use most of the time. And then Synapse Studio is a pretty good overview of the interface. What I had was on the slide. Those were the main components there. There's Synapse Studio, but he showed you a little bit more of it when you set it up, like your home page, and then additional messages that you can receive about your pipeline runs and errors and so forth. So pretty good introductory videos. One thing I will do here once we get started on the hands-on exercises, we'll do that right after. I think that we'll do that right after we recap, because we have quite a bit to go through and make sure everyone's set up and can do what they need to do in Synapse Analytics. Is that we will we'll go to that right after it, and then we'll run some of these examples in our code also that we have. So the PySpark data frame, and then run this example of using the SQL Server list pool, also making sure that we can do both Synapse Analytics, and then getting through our homework 1, then hands-on exercises. So a lot to do in this last hour and 20 minutes. So we'll go ahead and get started. Okay. Well, one of the biggest themes in this class, since it's called Cloud Solutions and API Integration, so why use APIs for data science workflows? We covered this, different types of APIs and how you may use the use cases, how you may use them with different use cases for analytical purposes. And we did talk about a little bit about automation and real-time analytics, and then being able to model deployment too. So this is a recap, but specifically focused on how we utilize it within our workflows in data science, more so than just the use cases and talking about automation and so forth. So APIs can enhance data accessibility, data quality, and automate data integration. Those are probably the 3 biggest things. It makes data like the cryptocurrency, live coin watch data more available or accessible, because you have some program going out and get it. You don't have to pull it all by hand. You can run scripts or API libraries for data quality, make sure it's of the best quality. Also, pulling from APIs, we learned generally they'll return the data the way it should be to you. So there's not a lot of guessing or cleanup or anything like that. It should already be a good data source that's coming back to you. It doesn't always happen, but it ensures some data quality and consistency, and automating that data integration process, so you don't always have to go out and collect data by hand or run a script or do other things. You just have it, especially important in AI and machine learning that depends on new data that's being constantly fed into the models for improvement. So it's important direct governed access to data sources such as databases, web service, and enterprise systems. That's what I was trying to say. It's a governed access. So they define the rules behind the scenes and serve it to you through a web service or database. Real-time analytics allows them to deploy those models and even able to continually update and deploy the models whenever new data is available. So that's how machine learning works is that you build a model and you take some new data in, and then the algorithm learns from it or takes in that new data, can run a variety of different stepwise type algorithms to be able to improve your model anytime new data is coming through. So it's constantly iteratively updating and deploying whenever the new data is available, particularly with real-time analytics, like the fraud example that we received, or I talked about at the beginning of class, when within like 10 minutes or 15 minutes of someone using my card at a couple places is already shut off. So it's like near real time that they could detect that type of fraud. So maybe that's against a pre-existing model, but having machine learning models that are constantly improving or AI models that are constantly improving in the moment is a huge advantage of machine learning and AI itself. And then model deployment and management. So you can deploy the model via an API, REST API usually. And it can be easily accessed by other systems and simplifies the management of the model. So that's the way we'll deploy our model for our project, is by a REST API. So others can connectivity or can use it programmatically. They can connect to the REST API and use it programmatically. So here's an idea. This is a really good picture of our process from start to finish, like what we're trying to do in this class as far as like your end-to-end data science, engineering and data science workflow, or a machine learning model. So you have the data from these apps, and maybe REST API, likely REST APIs or databases. You're ingesting all of that. So you might use something often like Python you could use if you script it. Or if you're in Azure, you'd use Azure Data Factory to connect to these programmatically, and you set up your pipelines and workflows and then output it to Data Lake. That's actually what you do. This is your first part. What you're doing in homework 1 is ingesting data and then putting the JSON file from the API and then putting that file into the Data Lake. So from there, you can do things like cleaning, exploring, feature engineering. Usually this is when you start to build the model. You have a Python, or you have some type of process or Python or whatever it might be to clean up the data and do those transformations. We learned with Databricks that this might be, you have a bronze, silver, and gold. This would be like your silver step, where you're doing it and getting your data ready for where it needs for analysis and those transformations and applying rules and so forth. Then you do your modeling in some type of platform. You do it in Spark. We'll do ours in Dataiku now. You could do it in ML library or Databricks. And then you validate the model. And then after you do that, you start to monitor it by a dashboard or application. And why you use an API is because you're constantly receiving new data. It's constantly coming in. And you're constantly transforming it, updating your model, and representing it here. It's continuous feedback. I'd say this whole thing is continuous feedback, really, because you get new data, then you have these processes that update the data, update your models, and then validate your models and present your models for monitoring and maintenance and those predictions. Right. So benefits of data collection using APIs and data pipelines makes efficient data retrieval. One of the good things about REST APIs is that they're stateless. If you send it a request, it always returns the same expected result. It doesn't change over time or anything like that. You can always depend on it as a seamless data source or reliable data source. And APIs also provide access to diverse data sources, so that whole ecosystem of REST APIs that you can get data from. Automated data processing. So oftentimes there's processing behind the scenes that happen with APIs, so you don't have to worry about doing all that pre-processing. So those pipelines are automatically automate and collect the data and transform it. Then you can also collect it and do the same also. It increases efficiency and accuracy of processing the data. Can enhance data quality. One of the advantages of the automated data processing is you don't have to pull it by hand. The more you have to do manually or like fix up with your hands yourself, any time you're doing it non-programmatically, that's when errors may occur. So being able to try to do that through the reduction of manual errors improves the reliability and quality of the data. And it's scalability and flexibility, so they allow you to collect data at scale and accommodate the evolving needs. So sometimes there could be so much data coming in is that you just can't do it manually, or you can only have so many people. It helps you programmatically and your resources scale according to your needs. So helps with data retrieval, automated data processing. It automates that for you, where you can create pipelines for additional automation. Data quality through the reduction of manual errors, and scalability and flexibility. Okay. So this one's using Synapse ADF, the REST connector, to be able to connect to API. So this is what the process looks like in Data Factory. We will do something very, very similar within Synapse Analytics. So it has a version of Azure Data Factory. And then we'll also do this as part of our final project and homework too. So I'll go ahead and drop this link in there here in a second once I get past this video.
Hi all, welcome to the channel.
It's about 10 minutes, so I'll give everyone 10 minutes, or we'll give everyone till 8 o'clock to view this. It'll show end to end. So how you create a pipeline, how you set up that data set, the integration that you use to connect to the REST API, and then how to load that into a database table in an Azure SQL database. Go ahead, copy the video, and we'll call this Synapse Analytics. Oops. We'll call this using Synapse ADF for REST connector. Okay. So go ahead and watch that over the next 10 minutes. We'll restart maybe like 8:01 or 8:02. But it'll give you a really good picture on how to set this up, how we'll set up the live coin watch API connectors within Data Factory to pull the data automatically. So I'll go ahead and mute and stop my camera until then. We'll come back at 8:02. Just a little bit over 10 minutes if you start watching it now. So I'll see you then. All right, everyone, I'm back. So a good video of how to build a simple pipeline using the copy utility within Azure Data Factory to do a source to target mapping. So they took the source as the REST API that they were using. Ours would be the Live Coin Watch API, and then we would map it to some target. So it'd be maybe it's a target file, a target CSV within the data lake, or maybe it's a table that you build in the data lake, like one of those NoSQL tables, or perhaps you are loading it, parsing the JSON files and mapping it to a table within your SQL data warehouse. Or it could be to any number of sources or destination sources. Those three are probably the most common, but it takes you through all the steps of setting up linked sources and doing that mapping of the data. So we're going to try to get to that and do one of these tonight, using the class 3 and class 4 hands-on exercises to do that with CSV files. And then if we get to it, it's pretty optimistic for us to get to the connecting the REST API to a table or to a data source. But we'll try to get through as much as we can tonight and catch up, with the goal of it really becoming really familiar with Azure Synapse Analytics and being able to navigate it and create pipelines and what you need out of it, do the processing that you need out of the platform. Okay. So before we get started with with Synapse Analytics, everybody needs to set it up as a service. So there's this file, it's called Synapse Setup and Querying Guide. And what we're going to do is set up the service, connecting it to our data lake, and then use the SQL serverless pool, and then query it using a Spark notebook. And then set up this Spark notebook pool. The Spark pool as we do it. Okay. So this is where everybody likely want to follow along. So we'll do Synapse Setup and Data Lake Querying Guide. I'll keep this open. Bring a screen over here so everyone can follow along with the steps. And then you'll also have the recording to go along with it. So we'll do this. We'll go to portal.azure.com. Remember to go to our resource group. If you're at home, you can see the resource group, or likely now you'll have this in your resources. It's one of the items you frequently pick. You can do it that way too. I'm going to go to ODSA Data Engineering. And then we had our existing services here. So now if you'd like, maybe it'd save you a little bit of money, you could delete these two resource groups. We no longer need Databricks or Key Vault. But don't delete your data lake storage or Gen 2 storage. We still need that. So you could ask to delete these resources. So don't want to delete the resource group. So let's just do these one at a time. It says delete resource group. And I need to go inside of each one of these and delete it. So if you clicked on Databricks, I thought I could do it from that view, but you can go inside of each one of these resources and delete a resource. So I go back to my data engineering. It takes just a little bit for the resource to finalize the deletion. There's some things that the managed service does behind the scenes. Microsoft does behind the scenes as part of platform as a service. So we'll delete the key vault also. That should be relatively fast, I would think. So when they're successful, you'll see that that resource has been deleted and you no longer see it in your resource groups. That's just a little side note. But we'll go ahead and follow these directions and set up Synapse Analytics. So within our resource group, do Synapse Analytics. Create that resource. All right, so this is what we saw earlier. We have a few things to configure here. Yes, and the most importantly are the ones with the star next to them. So with these are already pre-filled. You have your subscription, you have your resource group that you should be familiar with. Create a resource name. Just something that you would remember. You could do ODSA Synapse.
Hey, Jeremy.
Yeah.
Sorry, I'm behind already. So you were in the resource group, and then you went to create resource from within there, and did Synapse Analytics, and then it was Azure Synapse Analytics, that first one?
Yes, correct.
Okay.
Yep. Okay. ODSA Synapse Analytics. Okay. Yeah, I did that. I went to the marketplace, so now I'm creating the Synapse workspace inside of there. So workspace name, just call it ODSA Synapse Analytics. Then if you'd like to put your initials there. I never remember if it has to be, yeah, this one has to be entirely unique. So that should be unique, ODSA Synapse Analytics, and then your initials at the end. We'll go US East, since that's what we're setting it up before. I think we did US East 2. Okay, so we can select Data Lake Storage Gen 2. It's from our subscription. And then you'll have your account name. So you saw inside of your subscription, it's your Data Lake account name. We just called it ODSA Data, and then first name and last name. And then you can see these are the folders within your Data Lake. So if I was to open Data Explorer or Azure Storage Explorer, if you have this installed, or you could go to the service and see this. But you would see it says storage account, the ODSA, Jeremy Bergman. And then you go to your blob containers, which are your folders. Because Gen 2 is built on top of blob storage, but optimized for data analytics. And you'll see the curated, processed, and raw data, those all these folders you created. So let's go ahead and do connect to raw data. Process data, curated data. Yep. So within raw data, I had created this crypto data folder. And within the bronze is where I put these CSV files. So you don't necessarily have to do that, but it'll connect you to this whole file structure. So when I do raw data, I'll see this crypto data folder I created in there along with the CSV files. Well, along with these subfolders and then CSV files. So if you aren't familiar with the CSV files, I'll go ahead and drop that in here now. I dropped them earlier in the class, but I'll go ahead and drop them again because we will use these. So you're free to create whatever file structure you want. I feel like the way that instructions were having us create it was kind of silly, but I'll drop these CSV files in there. So fact coin history and fact overview history are what we are concerned with. I'm dragging these over to this now, to Slack. CSV files. Well, honestly, what I'd prefer to do instead of having these bronze and gold and silver folders, I'm going to delete those. So inside of what we created the very first class was curated, processed in raw data. So if you connect to your raw data and you create a crypto data folder inside of there, why don't we just put our CSV files in there? You'll say that's a raw data and it's crypto data. And we can put our files in there. So if you don't have Azure storage data or data storage, you can do this through your service. Through your web browser. So if we went to our storage account, we'll go through resource groups. Click to the ODSA subscription. You click our resource, ODSA data, Jeremy Bergman, inside of our resource group. Now we should be able to go to storage browser. If you go to blob containers, you can see those folders that we initially created. And within raw data, which is the one that we're using, have a folder called crypto data and those CSV files there. So that's the way you can do that through the web browser, and you can upload your files that way. So you can do it using that, or you can use the Storage Explorer like I used. Either way works okay. So just making sure everyone has the data and it's in that spot for configuration for the Synapse workspace. So ODSA data, Jeremy Bergman is the name of the data lake storage resource. We're connecting to that raw data folder and anything in there. Yep, and we want to do this, assign myself to the blob storage data. Right, so for security, this is okay. Use both local and Microsoft Entra ID. So I would change this server SQL admin to it, your first initial and last name, so you know what your login name will be to the SQL serverless pool, to your SQL pools. And then set whatever the password you would like for it to be. So something you can remember because it'll be like an administrator password to your database. And you can do disable down here. Use all the default settings. Networking is fine. We don't need to do any special security or virtual network. Let's not worry about tags today. And see, that's a way that you could search for it in Microsoft Azure portal. We won't worry about it. Okay. And then review and create. So Microsoft will assign you a SQL pool automatically. And here's your information. There's a workspace name that we created. Our Gen 2 data lake account that we've connected to, and our folder, and our default contributor role. Go ahead and create. You'll go through here. It'll tell you if there's anything wrong with it. It'll give you an error. It should not take as long as the Spark pools took with Databricks. So it'll take probably a minute or two. So deployment's in progress. So what we'll do once it's set up is that your serverless SQL pool will be set up. You'll use that storage name that you created. And then it'll be raw data and then crypto data. And then we'll do the fat coin history there. So it won't be quite this whole path. But we will do that through CSV since that's what's stored there. And then if you had a query, if you had a Parquet file there already, if you had already converted it to a table, Parquet table, you could query that directly too. But we'll just do this from CSV file. No, it is taking just a few minutes. And walk through the rest of this while we wait. So we'll do that through the serverless SQL pool that we set up and Synapse Spark Notebook. We'll connect to it that way also into a Spark data frame. If we're good with that, we should be ready to go for the rest of the class if we can do these two things. So still waiting on that deployment. I say that it shouldn't take as long, but there is a lot to set up. And then Synapse Analytics. Sorry. But there is quite a bit. It's that all-inclusive IDE and platform. So there's quite a bit to set up and configure. Okay, I only took probably 3 minutes. Oh, started at 8:20, ended at 8:23. Yeah, 3 minutes. So what you can do there is go back to your resource group. And now you'll see Synapse Analytics here with the name that you gave with it. So once that's set up, we can click on that. There are a whole bunch of other settings that we can do here if we'd like. We can even do some more settings on our SQL pools or Spark pools and whatever. And then configure it whether it's serverless or not service and set some compute to it and monitoring and automation or so forth. But we aren't going to worry about that too much in this class now. But if you go to overview, you can read some documentation about it. Here's all of your endpoints that you might find useful. And here's even your data lake that you're connected to in the folder and your SQL admin username. So this is still valuable to go into your resource and see all these. So now, since it's set up, we can open Synapse Studio. So usually I would have set up Synapse Analytics earlier in the class. And we won't have to set it up now, but we'll go ahead and do it since we're heading that direction. Usually Databricks was replacing this, but Synapse Analytics, I've been pretty successful with using it overall. I like the platform. So just loading up. All right, so this looks familiar. It's the IDE, the interface for this development environment we saw in the video. So you have some shortcuts. You can do a quick ingest of data or explore it, Explorer, or even connect to these Power or data sources with Power BI. But the first thing we are going to do is that we're going to go ahead and query the file using the SQL Server pool. So how you can do that, since we're creating a new script, you can go to Develop. You hit the plus sign. There are a couple of different scripts. A notebook will be a Apache or a Spark notebook. You can create a data flow that you can use in a pipeline. So your transformations is like a Power BI data flow where you can transform your data through that. KQL is the real-time language that we talked about with the Data Explorer. We talked about that in the last lecture. You can write a KQL script for streaming data. But all we want is a SQL script. So now we can try to copy and paste this out of the PDF. Get rid of that part of it. So a few important parts to this query. You'll see one is open row set. So open row set is like allows you to do this bulk command inside of SQL. It's an important part of it because then you say you want to, allows you to do additional operations. So you can bulk load this CSV file from this data lake location with the format CSV. In a CSV file, your terminator is usually a comma because it's comma separated files. Row terminator, usually there's some character at the end of each line in CSV file that's hidden. And you say your first row is 2 because what it looks like is all the headers are in the first row and your data starts on the second row. So let's do a couple of things here. Let's change your storage over to our data lake storage name. So the name of that was, and I forgot already, it's the ODSA data first and last name. So in that part right there where I said your storage, you can put ODSA data first and last name. And then the DFS core windows.net, that is like the URL for your data lake storage. The container that we set was raw data. And I got rid of this file structure. So now what I have inside of it is a folder called crypto data. And then the file name is FatCoin history. So I'll give everyone just a second to catch up with that. And anytime you're working with the file, you'll see if you make a change, this will appear here up here at publish all. So publish all doesn't run your code, but you have to publish your changes before you can run it. So I'm going to go ahead and publish it. Let's give this script like a descriptive name. Let's give it FatCoin. Let's see. Data lake, FatCoin, history, query, SQL.
Hey, Jeremy.
Call it SQL. Yeah.
I just deleted everything. My ODSA engineering data group, my resource group, I just deleted on accident.
Oh, you deleted your resource group? Ooh.
Yep. So I have to start all over from exercise 1.
So not too bad. So you want to do 2 things. You set up a new resource group.
Yeah, set up
and
a
then
new
set up
resource.
your data
Yep.
lake storage.
Yep.
Is all we
I'll
need
get to
now.
that.
So you can set this up. And this is a good recap anyway. I guess you'll have to set up Synapse Analytics if you were just setting that up too. But just your data lake
I had it
now.
ready. I'll get it done.
Analytics. Yeah. So you can click on this and then storage browser and create your folders and put those CSV files in, the blob containers and everything. It set you back a few minutes, at least.
Yeah.
All right. Where was I? I was just letting everyone catch up with what we had here and then the publish all. And I renamed that script. Just going over here, you can click rename. So any changes you make, you'll see that come up here and then you publish your changes. That's where you can do version control. In particular, if you have you can configure a Git account and go back to previous versions of it. But let's go ahead and give this a try. So connect to, it's your built-in SQL pool. Just use the master database. That's like your default database. This is actually a Microsoft SQL Server database. And by default, their default database is called master when you set up a server. Let's go ahead and run. Schema cannot be determined from the data files for file format CSV. Please use the with clause of open data set to define the schema. Yeah, I do have to have a with somewhere. I forgot where I put it though. I hardly ever commit anything to memory. So let's just put it in Google this time. Okay, you can easily query CSV files. I find it so much easier to do these. Just ask AI to do it instead of searching through Google results. Import CSV files. How to use Open Row Set. Let's just go with Learn Microsoft how to use Open Row Set. Okay. So the Open Row Set bulk function is what's allowing us to do that. The Open Row Set reads contents of a remote data source, returns the contents as a set of rows. So Open Row Set will connect to things. Like even if it wasn't a data lake, it might be like a file on your computer if you had a local server or something like that. So it's used in regular Microsoft. It's used in Microsoft SQL Server, but within the cloud in particular to connect to your Azure data storage. Okay. It says can be referenced in the from clause like we did. Okay, so they had a quick Open Row Set without data source can be used to directly read the contents of the files from the URL. Okay, so it's going to give me like all my options here. And the one that we're missing is with. Okay, so you have to define your column names here since we don't have a schema, I believe, is what it's asking me to do. So one of my favorite things to do, of course, ask Claude. So we'll type that in. And the other part of that error message, it might have been up in the other window. Or maybe not. Where did it? We'll just say it's missing with. Okay, so it tells me that's really nice. Don't have to read through the technical documentation quite as much and figure it out. So yeah, it needs it for, in this case, to know what columns to read inside of your data lake storage. It's especially important when the CSV files might not include column headers. Okay. Say, how can I include the header row as a schema? This query. see if we can do this. Okay. So it changes the query up a little bit. Let's try to do this one. So I need to go back into my Synapse Analytics workspace because I forgot what window it was open in the other one. Oh, it's actually this one, isn't it? Okay. Going back to the query, let's paste this new one. This new part in here at least. Okay. So I have this bulk location where the two biggest changes are the parser version is equal to 2.0 and the header row is equal to 2. So now it's trying to read the header to figure out what the column should be instead of having to define each column, which makes it a little bit easier. We'll see if it works. We'll go ahead and put this into Slack. Say dynamic way to read column, can't type names in CSV file in data lake from SQL from your SQL Synapse SQL instance. Okay. So I put that in our channel. Go ahead and publish that change. Then I'll run this. And that works. So if we change it to this parser version, it's going to look at the headers in that file, which were fat coin history. We were doing that from fat coin history. I'm just pulling up this CSV file. You can see it does history date, history dot rate, all the way over to symbol. And it loads all of the records successfully. Okay. Well, not load it, but that's the way the file looks, and then you query the CSV file. Okay. So that's a success. Let's go ahead and try to also put this in a data frame in Spark Notebook. So I'm going to go ahead and carry this over because we're going to need that full path anyway to the CSV file that we're trying to read from the data lake. So let's go ahead and we can just go ahead and do another workbook. You can develop a notebook, hit plus develop a notebook. So we're already doing PySpark with Python. That's what we want. Before I do anything, I'm going to go ahead and paste this URL so I don't lose it. And if you wanted to at this point, we could start setting up our Apache Spark pool instead of trying to put this code in here. So we'll go ahead and do that. So right now, we don't have a pool to attach Apache Spark to. This looks very familiar to Databricks because you do the same thing in Databricks as you select the compute for it. You'll do the same here. So you can do new Apache Spark pool. On the last screen I went up here to attach to. Then you go to manage pools. You can do a new Apache Spark pool. You see, this one's probably a little bit easier to set up. You don't have to select the virtual machines. You can just select a pool and then do this up and down. Do the number of nodes and the node sizes. So let's give this Apache Spark pool a name, just like it's our little baby. We'll call this guy ODSA Spark. ODSA Spark, first name and last name, or you can do your initials if you want. It must be 1 in 15 characters long. Occasionally they have a weird requirement, so let's just go ODSA Spark and then your initials. Okay. Node size family, they'll automatically optimize memory for you. Let's go with the small instance. You can see dramatically cheaper if you went extra large, $27 to $90 per hour. But your small is $1.71. And this has the same thing. It'll shut off after like 120 minutes of use, or maybe even less on this one. Dynamically allocate executors. You can do that. I thought it did automatically, but we could set it not to. Okay, additional settings. This one will actually pause after 15 minutes, which is good. I don't think you even really need it for 120 minutes. If you haven't run anything in 15 minutes, you could probably shut it down and start it back up. You have different Apache Spark versions, and it shows all of your R and Python versions. They automatically do these updates being a hosted service. Apache Spark configuration. You can import a configuration if you wanted. We'll just leave all these defaults. Don't need any tags. We've done that before. Then review and create. So they should actually really be faster than the other one, but I just said that a second ago. So yeah, it says only 1 or 2 minutes and it's a small instance. So we'll wait for that. It's currently deploying. If you go up here to your bell, you can get all the notifications. Meantime, we'll start pasting some of this code in here. Okay, so we did the new workbook. Set up that instance for the Apache Spark pool compute. Starting it up right now. Our pool, I should call it. It's our compute pool. So we'll just do this simple piece of code. So this does have a slightly different syntax than the SQL Server list pool did. So you see here, you have this library Spark, and then spark.read, and then this function option. And then you have some parameters. You say you read the header is true, and then the location of your CSV. So you'll see this full path name, the ABF SS. And then you have your container, which would be raw data. Storage would be your account name. Then we have the rest of our path here. So instead of crypto bronze, fat coin history, is crypto data. Okay. Now, once this pool is started, oh, yeah, it already started it, so that's pretty fast. So once that's configured, let's go ahead and publish these results for this code. Let's rename our notebook, huh? So we'll call this DL fact coin history SQL, or not SQL, Spark Python. Okay. So it says from the data lake, fact coin history, Spark Python. So we've set it up and it's deployed. We still have to set up our instance. So it's at ODSA Spark JB were your initials. Now we should be able to start it, and you can start it automatically by running. So it's take a few seconds to start the instance. You had to set up the instance when you chose it, but if it's off, it has to restart the instance. Taking just a little bit can sometimes. A small instance usually doesn't take that long. And while we do, and the next thing I want to do is, now that we have both of these, we're going to revisit homework 1 and make sure everyone is able to recreate that. Then we can recreate that using Synapse Analytics. Oh, taking longer than I hoped. So we'll just go ahead and open that up while we're waiting. Let me find my notes on it first. Good time to find my notes on it while that's running. Still running after minute 55. Okay. Pulling my homework up as that continues, homework assignment, as that continues to run. All right, so for the homework, we'll just go ahead and while that Spark session is kind of set up and run. So there's a version in here inside of Slack. It's a greatly simplified version from the Databricks and the Key Vault version of this homework. Those were just largely barriers to getting this homework done. And we're no longer doing anything with TO203. And let me make sure this is the correct version. Instead of Databricks, we're using Synapse. So what we're really trying to do here is do our very first connect to the REST API using a Spark notebook. But now instead, we want to, instead of using Databricks, we now want to use Spark inside of, Synapse Analytics instead. So that finally completed. So that CSV file, it took the session 33 minutes, 41 seconds to start, and the command executed in 19 seconds. Put this all in a Spark data frame from CSV, and then here's the top 10 records out of the file. So this is cool now that we don't have to officially load it into a table or something like that to do it. We can just read it as it is from the data lake, whether it's in a Parquet file, a table, or CSV file. I think maybe there's some other options here too, other than CSV, like Excel and stuff like that, but usually best off keeping it, might as well keep it in a CSV file. But sometimes there's some other formats that you can read out of too. Okay. So I'm just going to continue in this notebook. I want to go quickly through homework 1 and have everyone try to complete this. Everybody try to successfully complete this themselves before I assign homework 2. So homework 2 will be taking that API connection and creating a Synapse Analytics pipeline to be able to automatically update data inside of the Synapse data warehouse. But for homework 1, let's make sure we can do that first. So what you want to do is register with the Live Coin Watch REST API, develop the Python scripts, store data securely in the data lake. So this will return a JSON response, storing that JSON response inside of data lake storage, and we aren't even worried about exploring the data anymore. Okay. So yep, you needed the requirements is hands-on exercise, and you don't have to complete the hands-on 2 exercise with everything in box to be able to do this, but that hands-on exercise will give you a thorough understanding of a REST API and all the different operations that go along with it. So like your puts, your gets, your deletes. Then I'm forgetting 1 too, but those operations, being able to do it in Python, so forth. So steps here to get that live API key. This one's fairly straightforward. You do have to register for Live Coin Watch API. I believe I've just done it with my Google account. You can do it with your Google account, or you can sign up with your email account. So once you do that, I sign in with my Google account. And this is a lot simpler than the box, the OAuth 2 that we did. OAuth 2 is secure, but it's a whole process and methodology that's can be difficult to configure too. So if you signed up, you can see your edit profile. You'll see some options there. And your API keys in there so you can copy it. This is not OAuth 2. All you need is your API key for this API to access your REST API. You have 10,000 credits remaining. Usually API call takes so many credits depending on how much data you get back from it. So as long as you don't hit that limit, you'll be fine. And that's a lot, actually, for this API. You can get quite a bit of data. So let's do one of these. Let's do one of these endpoints. Let's do that overview history. So this is an endpoint they got that fact overview history data from. That CSV file that we were just looking at. Did I mention which ones to get it from here? So you can get all of the coins single. You can get the current quote for all the coin, or for BTC. If I was to run that, it'd be like the current quote as of right now. So it has some historical information. It should have like the current price in here, current price of Bitcoin, and so forth. Then you can go get some historical information about it, which is what the CSV files have in it. Some historical information and some information of overall history. This is overall market cap, and then coin history, coin single and coin history. So that was the coin single for Bitcoin. Then you could get historical information. You give it, remember we have body of a API request to send it some, I don't like parameters, but I like your where clause to tell it, get it between some parameters to instruct the API on what information to get. These are all GET requests. So if you do a start and an end, you'll see history, and you'll see each one of these dates with their relative history on them. So I think these are like every 15 minutes apart or something like that, if I remember correctly. But anyway, idea is that we have our API key. Let's go ahead and just save that in our code now. So I'm just going to do it in the same workbook. I'm just going to save it right there. So what we were trying to do with the key vault was store this in the vault securely instead of right in your code, and then be able to call that key whenever you needed it in the program. But that was causing some a lot of barriers too with access controls, security and access controls. So we won't worry about that. We'll just put it directly in our code. So we have coins single, coins list. Your code should include the request headers, response parsing, and basic logging. So this is where I drew a blank on the name, but Postman could help you out. So you can start developing your request here in Postman. And maybe it's just my connection today that's slow. But you can develop it here in Postman and then export your Python code. And it should work fairly well. So what I would do is inside of your workspace, And I'll go just a few minutes over, but this won't take too much. This won't take too much longer. And I like everyone to try this and try to finish up homework 1 and hand it in, because we can still do that, assuming that you get all the way through your Synapse setup. So I always use Postman. Sometimes there's just a library that you can import or a collection like the Box APIs. And it would actually be this one. Or you can set up your own where you start to explore it yourself. So this is where go into the documentation is helpful. So in the headers, you would see you need something like X API key, and then you put your API key there. And you could set up variables in your collection and have it in all of them, but I just usually set these up one by one. And so you have your post command. These are actually post commands, not get commands. So you post this information and it returns your JSON file. So it's like yeah. So post commands for each one of these. This one should probably have an X API key, although I end up putting that in the header and that probably still works okay. So let's just do coins, the coins list. So I put that in the key. I have this little JSON script inside of the body, and I just say raw format. And then I know my endpoint that I want to get the information from. It's a raw format, and down here it's JSON. Then you say it's JSON. So it reads it as a raw JSON text format. So I say currency USD, sort by rank of the coins. I guess I'm only getting 2 of them. Let's go ahead and see what the result is. So yep, it returns result BTC and ETH. Just get Ethereum, the top 2 coins by market cap. And this is like the current hour of the day, week, month, so forth. This would be the current quotes for these 2. So you use this as your friend. You can then come over here and code snippet and do Python. So the Python request library, this should work pretty well. This should work pretty well within Spark Python. You can see you have your request library in JSON. And here's your endpoint. Here is that body payload that you're sending. Here are your headers with the API key and what content type you want returned. And then you put that in your request and print response. So pretty straightforward piece of Python code. And what helps is you can do it in here and really figure it out and then just export your code. So let's go ahead and just give this a try. And then here's the key. It's still the same key, but you could copy and paste or use that inside of Postman. Yep, and then it returns the JSON. So your JSON is in this response.txt. It returns a full JSON response. And then you're just converting that response to text. The final step here, so I give some parameters to try to collect this information for you to go out and explore. Go out and explore that API a little bit to get the information that you want. And then store this JSON response in your data lake. And instead of Databricks, this would be Synapse. Spark. Python notebook. So that's all I'm asking for now. And the last step you can do, we have some code for this. Create a Spark pool. I don't. And I deleted the code that I used. I deleted the code that I used to save this JSON file to the data lake. But I'll let the class do that and figure that out. And it's going to be something similar to this. It'll be like a Spark write option, but you probably won't use Spark for it. I'll let you be creative on how you do it. But you'll take that response and then just write that back to the crypto data folder as a JSON file. So I'll put this homework out here, and that's all there is to it now, is to form these requests that get you this information, and then save those JSON files into, save those as crypto data. Save those JSON files into the data lake. I think that covers that pretty well. We didn't get to the hands-on exercises from last week, but we made pretty good progress here. How does everybody feel about this? Like feedback, or feel like something you can do? Thumbs up, thumbs down, or questions? From anybody? I think it's a simplified version of what we were doing before, at least easier to configure, less barriers, but the same trying to do before with Databricks. Yeah,
I think I kind of got lost at the off spot on Postman. How did you
go back to that real quick.
How did you off with between Postman and Litecoin Watch? Or do you not have to?
So in the header, I just have this X API key, and then your authorization, your API key. So this one is like a simple, just like all you need is the API key to say who you are, because it's
Where did
not
you get
like the Box API.
You said X.
Where'd I get it? Here you go.
Yeah, the X API part specifically.
That's where you have to look at the documentation a little bit closer. So Livecoin Watch. So I'll go to, let's read the docs. So yeah, I had like that in class 2, like the 6-step like methodology. And it's like getting your authorization token and then reading the documents and stuff like that. So you'd go down to resources. Those would be your different endpoints. And now you can see them from that playground too. You can see like they have these different playgrounds to see like see what each one of these endpoints does. But what this documentation does is that if you went to like coins.single, it shows you, and then you could read shell if you wanted, but I just do Python. You actually hardly even have to go to Postman. You could almost just copy this straight out and put your API key in there. That's basically what I did. Or I did it in Postman because I just like to like play around with it there. But you could just take this code out and put your API key and run it and get that result. This API dive, this is like really well documented with good examples. And it shows you like what parts are the body of your request, what your headers need to be. So like asking what content type it is, and then there's your API key for authentication, which is almost exactly what I have here out of Postman. Except I'm using the coins list endpoint. And then I'm sending what I need to that endpoint, the body. So some of those limiting factors, like a where clause, sort of, in database land. So I say like currency is USD, so returning in US dollars, your data, sort it, just return 2 of them. And none of the metadata that goes along with it. If I was to change that, give me a different result. So it's almost exactly the same form. This API is a pretty much more straightforward example than the box API is, with all of like the authorization tokens and access token and like having to refresh it and everything. So yeah, this, when I say change that metadata, it gives me like all the metadata on the coins, and then you could see that. What's that endpoint? That endpoint was coins list. Resources, coins list. So here's what the stuff that you put in your body request. I just changed like that. Metadata is equal to 2, or from false to true. And then the headers are pretty much the same all the way across the endpoints, I think. I don't think we have any URL parameters. And then it shows you an example of the results that are returned that you should get. So long explanation for one question, Luke, where you say, where do you know where to put your API key, but you can see it in the documentation. It's usually like that. That's pretty common for it to be X-API-key if it's not OAuth 2. If it's just a REST API with basic API key authentication. That makes sense?
Yeah, I think, although I'm still having trouble getting it to work in Postman, but it makes sense.
You don't have to necessarily use Postman. I personally like it as a tool, especially with APIs that have more complicated authentication protocols like OAuth 2. I often struggle with those. And it's like you have to pass different tokens and stuff like that. It's like you send your API key to one, and then you get back an access token, and then like a refresh token, and like how does that all like work together? It gives you like a playground to test things. And oftentimes what's good about Postman is maybe somebody already created it. I don't know if there'll be a live coin watch one. But for a lot of no, that's just mine. You could go search on the web for it if you wanted.
I just keep getting a 405 method not allowed. I don't know, maybe I'm doing something there.
Get in which one's a 405? I forgot.
It
I should
says
know that.
method not allowed.
Method not allowed. You have the you know what? Do you have it post instead of get? Or do you have a get instead of post? It should be a post.
Oh,
Method.
yeah. Maybe that's what I got. Ah, yeah, that is it. Cool.
I keep thinking it's a get because I'm just getting information. I'm sending a body more or less.
Yeah, and I think I just wasn't even thinking about that at all. But now it makes sense. Awesome. That got me unstuck because I
It's
was
like you're
just
submitting
redundantly
data, which is
putting
kind
in.
of weird.
Why did the params, authorization, and headers all have spaces for keys and values? I guess.
You're saying in that.
In
Why did
Postman,
these?
I have like a params, authorizations, and headers. Yeah, and each of them has the same sort of keys, values. What are the different? Like
What are these different ones?
Yeah, I mean, like if you do authorization and then you do like API key, it just
Usually
gives
it'll give you like some
key and a
default.
value.
You could try to do that. You could try to do it with this API. Like I just said none and then just defined it in the header. It's kind of just think of it as like your assistant. Sometimes if you just have an API key, that's what I'm saying. It's like this X API key variable with the dashes. That's pretty common for most of these, like API key authorizations. Usually they have like standard variables in them.
Okay.
So you could just potentially put it in there and it may or may not work.
Awesome.
Or like authorization is trying to help you set up like a WAF 2 authorization and then you give it like your access token. And then you have to set up a bunch of other stuff too. But this is by far, by far the most painful is OAuth 2. I don't know. Hopefully the box example is useful. I try to do it because it gives it variety, but it is a pain in the ass to configure.
Cool.
I may think of a different example going forward, but it seems like it's useful to show people OAuth 2. So in case they come across it, it's like the most complicated scheme, and if you could do that, you could do anything, but it does confuse people. And it can be hard to get to work. But yeah, for this, it's just your key. So I had to do no auth and do it in the headers and the body. And of course, Luke, we both know you can just put this stuff into Claude now. So I've been using Postman less, but sometimes when I'm really like trying to figure out how to get things to work, go to Postman still. I just have to like get my hands on it, my head around it to figure it out. Give me Python code for all of the live coin watch.com API endpoints. Bam. Maybe I might be able to create a Postman collection out of this too. That creates a class. It gets fancy. Setting your API key, making a request. then you call these functions for each one of the endpoints. I mean, a little complicated, but you can limit it to one if you wanted, and that's how you would use that. It's like a wrapper for the API, and then you'd use it. Kind of nifty. So can I create a Postman collection for this API? It probably will, because it's just like JSON behind the scenes.
That's cool.
So yeah, I'm a technology guy, as you know, Luke, and I never fail to be amazed by this and how much easier it makes my life. That's why I encourage people to do it. It's not like I want them to just go out and generate all this and not understand, but I'm like, this is like the future of just generate. You don't have to, it's not so painstaking to like create new code, having to go out and find examples or read technical documentation. I mean, to some degree, you still like, it's not perfect, so I have to go troubleshoot it. But this is a JSON. All those collections are JSON files. And then it tells you exactly how to use it.
Yeah, that's nice.
I have to get into the vibe coding. Have you heard of vibe coding?
Oh yeah, I'm a participant.
I don't think it's quite that good yet, but it's only a matter of time.
I don't know. It depends on what you're trying to make. Sometimes it's good enough to kind of get a point across, or depends on what you're trying to do. I think for
Maybe
example,
for a demo, do like a quick mock-up or demo concept.
Yeah, totally.
Like an MVP. You can mock
Or
something up real quick. I did that. Yeah.
little like Python assistants are pretty like Claude's good at those.
Yeah.
Cool.
I'm
Well, have a good
amazed
night,
by it
Jeremy. Yeah, me
every
too.
day, but it's awesome. Yeah, hopefully all this helps out. I feel like I should have done this to start now, but we'll get there. We'll still get there in the next 2 weeks.
For me, it's good to have an understanding of some of the overlaps anyways. I was even kind of wondering, like, we were using Google Colab, which feels a lot like this also. Like, can you do some of the same stuff in there?
Mm-hmm.
Because it's super cheap, you know? Like, even for like the pro account, I think it's like 10 or 20 bucks a month for like a base program or whatever. It's like not super expensive. So it's kind of interesting. I don't know.
Yeah. Yeah, no new tools being created faster than I even know I even keep up with. I know you can do it in Colab. Create these type of notebooks. Yeah, all these platforms have similar features, I guess.
Yeah, I mean, it's all Jupyter Notebook behind the scenes,
Data,
right?
yeah.
So, and that's open source, maybe.
Jupyter Notebook, I believe, is through Anaconda or Python. The Python open source.
Yeah,
Let's see.
makes sense.
It's open source through Anaconda. Anaconda project. Python projects still tend to be open source. Of course, not paying for it. Open source. Spun off from IPython, used to call it that. Usually it says what type of open source. There's a 3-clause BSD license. Forgot what the BSD license is, popular in Unix world. Permission-free software licenses, posing minimal restrictions. Yeah, some of them like you can't use for commercial use or whatever. So it's all part of that open licensing through that they have, the organization that created it. It's not through like Anaconda or anything like that. Just this project, this open source project, Project Jupiter, 2015. Just it became so popular, just integrated it into data science packages. And it's good. It's notebooks or whatever you want to say as a programmer. It's still good for like data scientists and thinking step by step in their process, and then like writing out all the steps of building their models and being able to evaluate it that way. Plus, I mean, a data scientist, you aren't like you can write code, but not necessarily like a software. You aren't a software developer or anything.
Yeah, makes sense.
I think you're perfectly fine. It's good for data and being able to do it step by step. All right. I won't keep you any longer, Luke.
No worries. Have a good night, Jeremy. Thanks for hanging out.
Yep. No
Good
problem.
night.
Always see you Friday or Wednesday.
Yep, sounds good.
All right. Later, Luke. All right. So that brings this class to a close. Advanced API integration for data science. Our next class will include, it will be, open up our lecture, will be building the machine learning models, cloud-based machine learning services. We will now start to evaluate this using Dataiku instead of Azure technologies, but idea is just to now start to take everything we learned, be able to create machine learning models, and then deploy them as services. So that is it for this lecture. I'm Jeremy Bergman, the instructor. This has been Advanced API Integration for Data Science. And we'll see you for the next lecture. Good night.